Students, this is 25th JE class. Look at that simple question on the board. The function f from R to R defined by. So is f is 1 1 onto 1 1 but not onto, right, so on. So let us solve this simple question. Look at this, you observe carefully how easily I solve this question. So look at this, students. I go for f dash x. So 2 into 1, 2 plus differentiation of sin x is cos x. So differentiation of sin x is cos x. We know that all cos x values lies between minus 1 and plus 1. So all cos x range of cos x is from minus 1 to plus 1. If I substitute all the numbers from minus 1 to plus 1, f dash x becomes positive. F dash x is strictly greater than 0. This implies fx is increasing function. Fx is increasing. Fx is increasing function. Strictly increasing. Fx is increasing. Therefore, fx is 1 1 function. Fx is 1 1 function. If a function is increasing, it must be 1 1. If a function is strictly increasing, it must be 1 1. I show that in the graph, right? Look at this, students. This is strictly increasing function. So for every x value, this is y value. If I take this x value this much, this is y value. This x value is related to this y value. This x value is related to this y value. Again, this x value is related to this y value. Every x value is related to only one y value. That means different elements are related to different elements. So distinct elements have distinct images. Y values, vertical values are y values. Horizontal values are x values, right? If for different x values we have different y values, what does it mean? So different elements, different x values related to different y values. One element is, one x value is related to only one y value. It is 1 1. It must be 1 1. So if a function is, look at this, students. If a curve is like this function is not strictly increasing, stationary, then decreasing. Look at this, students, it is not 1 1. So two different x values, this is y value. So x1, x2, so y1, this is also y1. Y values are equal. Two different x values related to same y1, same y value. This is not 1 1. Why it is not 1 1 means it is not a strictly increasing function. If a function is strictly increasing, so it must be 1 1. It must be 1 1. So right. So this is the concept. Whenever 1 1 is required to check, you go for whether it is increasing or decreasing. I hope you understood. For onto, clearly, for onto, y is equal to, so 2x plus sin x. So 2x plus sin x. Clearly, for every y value, for every real number r, there must be x value. So right, x value, y value. All y values are related. Whatever you take for this y, there must be corresponding x value. So it must be onto. Just analyzing is possible. You cannot solve it and show. So that means, look at this, students. If x tends to infinity, if I change x value from 0 to infinity, y also becomes infinity into 2, infinity plus anything is infinity. Y also moves towards infinity. If x moves towards minus infinity, y also moves infinity. So all y values are from minus infinity to plus infinity. Similarly, all x values are from minus infinity to plus infinity. That means range is equal to codomain. Range and codomain are equal. Range. So tell me range. Range means y values. So range is minus infinity to plus infinity. Range is minus infinity to plus infinity is nothing but a set of reals is equal to codomain R. So codomain. Range is becoming codomain. If range and codomain are equal, what do you say? It must be onto. So therefore, F is onto. F is onto. So F is onto. F is becoming both 1, 1 and onto. Which option is correct? Students, option A. First option is correct. Now let's move on to one more question. Let's go for next question. Next JEE question. So right. So next question is if f from 0 to infinity to 0 to infinity and fx is the side is closed, fx is x by 1 plus x, then f is option A 1 1 and onto, 1 1 and onto. Option B 1 1 but not onto. So option C onto but not 1 1. So option D neither 1 1 nor onto. Now again you go for f dash x. So go for f dash x. Solution f dash x is, so f dash x is, so quotient rule. Apply quotient rule for that. Denominator square. Denominator into differentiation of numerator minus numerator into, so differentiation of denominator. Denominator into differentiation of numerator minus numerator into differentiation of denominator. So it is 1 plus x minus x by 1 plus x whole square. 1 by 1 plus x whole square. From this it is so clear. We have square for all real values of x. 1 by 1 plus x whole square is strictly greater than 0. This implies fx is strictly increasing. Fx is strictly increasing. Therefore it is 1 1. Therefore f is 1 1 onto. So y equals x by 1 plus x. That implies cross multiply. Y plus yx equals x. Solve for x. So y equals x minus yx. What is common from that? X. So y equals 1 minus y into x. So therefore x is equal to, so y by 1 minus y. So given students all x values, given domain. This is domain. Domain means all x values are greater than or equal to 0. All x values are greater than or equal to 0. This implies all x values are greater than or equal to 0. Y value should be, so y value should be lies between 0 and 1. So 0 and 1, strictly less than 1. If y values are greater than 1, then x values becomes negative. If y values are greater than 1, x values becomes negative. Y value should be, so y value should lies between 0 and 1. Y value should lies between 0 and 1. If y lies between 0 and 1, so then x values becomes greater than or equal to 0. X values becomes greater than or equal to 0. From this it is so clear. So range, y values means range. So range, y is that y1? No, y does not exist. Y value should be strictly less than 1. So can be 0. Why 0 means 0 by anything is 0. X becomes 0. Correct? Right? So tell me that range is range. This is range. Tell me range. So 0 to 1. So 0 to 1. Range. So this side is closed. This side is open. Range is not equal to codomain. Not equal to codomain. Not equal to codomain. So right. 0 to infinity. 0 to infinity. Therefore, it is not onto. F is not onto. F is not onto or so right. Or so you can do like this one more way. Or so if I can choose y value from this 1. If y is equal to 1, x does not exist. Or you go for this one more simple way. If y equals 1 belongs to that second set, 0 to infinity, y equals 1 belongs to second set. So x equals 1 by 0 infinity. So does not belongs to, this is not a number. So does not exist. The number y 1, the number 1 of that second set is not related. Therefore y equals 1 is not an image. So not a image. We cannot relate 1 with infinity. Does infinity exist? Is it possible to connect 1 and infinity? No. Means 1 is not a image. So second set element is not related. Second set element is not related means not onto. When we say the function is onto, if all the elements of second set are related, otherwise it is not onto. I hope you understood. 1 but not onto. So which answer is correct? 1 but not onto. Let us go for one more question. So let us go for one more question. So write. So let's move on to next question. So right. So next question is if so next question is the range of the function. So next question is the range of the function fx equals x square plus x plus 2 by x square plus x plus 1, x belongs to R, is the range of the function. Option A, 1 to infinity. Option B, 1 to 11 by 7. Option C, 1 to 7 by 3. Option D, 1 to 7 by 5. So right, range of the function. Range means I should find out y values for the corresponding real numbers. Let us find that it's easy, students. So now I go for dividing that. So x square plus x plus 1, x square plus x plus 2. How many times? Once. 1 into x square plus x plus 1, x square plus x plus 1. So write 2 minus 1, 1. Therefore, fx can be written as p by q, any rational. So a by b. So any rational can be expressed as quotient plus remainder by divisor. A rational number, a proper fraction, any proper fraction can be expressed. Now, whatever it is, a rational number a by b can be expressed in the form of quotient plus remainder by divisor. You can cross check that. I go for that quotient 1 plus 1 by x square plus x plus 1. Even on simplifying this, you are going to get same thing. Now, so 1 plus 1 by, complete the square, calculate b value. So b is equal to half into x quotient 1. b square is 1 by 4. That is x square plus x plus 1 by 4 minus 1 by 4 plus 1. So fx is 1 plus 1 by a square plus 2ab plus b square, a plus b whole square, x plus 1 by 2 whole square. LCM, you find LCM of these two. 4 minus 1, it is 3 by 4. So 3 by 4, right? From this it is so clear as if x becomes infinity, if x tends to infinity, if I vary x values from 0 to infinity, look at this students, 0, infinity plus anything is infinity is for infinity plus any number is infinity, number by infinity is 0, fx becomes 1, that is lowest fx value is 1, right? So right, minimum value of y, minimum value of y is 1. For that maximum value, put x is equal to minus 1 by 2. So for the maximum value, put x is equal to minus 1 by 2. So you get y value, that implies y is equal to minus or plus of 0, 1 plus 3 by 4 by 3, 3 plus 4, 7 by 3. So right. So tell me minimum value of y 1, maximum value 7 by 3. Range means y values for that given function. So y values varies from 1 to 7 by 3. So 1 to 7 by 3. 1 to 7 by 3. Tell me range of the function, students. So option C correct. Let us solve one more question. Let us go for solving one more question. If fx is right, next question is right. if fx is sin x plus cos x and gx is x square minus 1, then graph g into fx is invertible in option A, first option 0 to pi by 2, option B minus pi by 4 to pi by 4, option C so minus 90 to plus 90, so minus 90 to plus 90, option D 0 to pi. First you calculate, first you find out graph x g into fx, so find out g into fx, right? Solution g into fx is equal to g into, tell me fx value, sin x plus cos x, sin x plus cos x, substitute the sin x plus cos x in g, so here it is g, put this sin x plus cos x in g, x square minus 1, that is for the x you write sin x plus cos x whole square, sin x plus cos x whole square minus 1, a plus b whole square. What is a plus b whole square? A square plus b square plus 2ab, a square sin square x plus cos square x plus 2 sin x cos x plus 2 sin x cos x minus 1, sin square plus cos square 1 get cancels, so right, so g into fx is equal to 2 sin x cos x, it is sin 2x, right? Now so actually invertible sin theta is invertible or sin x is invertible, sin x is invertible if x lies between, so minus 90 to plus 90, sin x is invertible. If I fix sin x becomes invertible, means it should become both 1 1 and onto, sin x becomes both 1 1 and onto if its domain is from minus 90 to plus 90. So you apply same thing for this, so apply that one for this one, sin 2x is invertible if so x in the place of x, here I am having 2x lies between minus pi by 2, so plus pi by 2, so divide by 2, so this implies minus pi by 4 less than or equal to x less than or equal to pi by 4. So tell me that, so domain for which graph is invertible, it is minus pi by 4 to plus pi by 4. So option B correct. I hope you understood this well, students. So right. Okay, let us stop this class. We shall continue in the next class. Thank you.